about a project titled An Online Recommendation System Using Deep Learning for Textile Products. Now coming to the introduction part, the implications of deploying this online recommendation system are far-reaching for both e-commerce platforms and users. E-commerce platform can expect increased customer engagement and retention as the personalized shopping experience fosters a stronger connection with users. The system's ability to suggest relevant cross-selling and upselling opportunities can boost sales and revenue for the platform. For users, the benefits are equally compelling. They can enjoy a hassle-free shopping journey, saving time and effort in searching for suitable textile products. The personalized recommendations cater to their unique tastes, enabling them to discover new and exciting items that align with their preferences. As users interact with the platform, the system continuously refines its understanding of their preferences, style choices, and unique shopping habits. Consequently, this dynamic learning process leads to increasingly precise and relevant recommendations, fostering customer loyalty and satisfaction. So our main objective for this project is to create a seamless and hassle-free shopping journey for users. By leveraging deep learning and NLP, the system can provide a highly curated selection of textile products that match each user's unique preferences and needs. This level of personalization not only saves users time and effort, but also enhances their overall satisfaction with the platform and encourages brand loyalty. The key objective of an online recommendation system using deep learning for textile products is to revolutionize the e-commerce experience by delivering personalized and contextually relevant product recommendations. Through data analytics, dynamic learning and NLP, the system aims to boost customer engagement, drive sales, and create a more enjoyable shopping journey for users. This ongoing learning process ensures that the recommendations become increasingly tailored and accurate, leading to a more satisfying shopping experience for users. Now coming to the requirements part, there are two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first upload textile dataset. The first step in creating an online recommendation system for textile products using deep learning is to obtain a suitable dataset. This dataset should consist of a diverse collection of textile products, images along with corresponding labels or categories that indicate the type of textile product each image representation. The dataset may also include textual information such as product descriptions, user reviews, and other relevant metadata. Second, train dataset with textile images using CNN. Once the textile dataset is uploaded, the next step is to train the deep learning model using convolutional neural networks, that is CNN. Here CNNs are well suited for image recommendation tasks, making them an ideal choice for processing the textile product images. During the training process, the model learns to extract meaningful features from the images and identifies patterns that differentiate one textile product from another. Third, recommend compatible items. After the CNN model is trained, it becomes capable of making predictions on new, unseen textile product images. When a user recommends and interacts with the online recommendation system and indicates their preferences or selects a specific item, the trained model can analyze this information and recommend compatible items. These recommendations are based on the model's understanding of the user's preferences, style choices, and the relationships it has learned between different textile products during the training phase. Fourth, accuracy and loss graph. During the training phase, it is essential to monitor the performance of the deep learning model and assess how well it is learning to make accurate predictions. The accuracy and loss graphs are common visualizations used for this purpose. The accuracy graph shows how well the model's prediction match the actual labels in the training dataset as the training progresses. It indicates the percentage of correctly classified examples, and ideally, it should show an increasing trend over epochs, that is training iterations. Now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are containing training pants and training shirts folders, in which there are some images of pants, and in this we have some images of shirts. In this folder model, we have some .h5 files which contain the deep learning algorithms information. These .hy files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions on new data or performing specific operations. Now these test shirts containing some images of shirts over here, and this textile recommendation is the Python file which is containing the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with our program. Now click on upload textile dataset button to upload dataset. Select dataset folder over here and click on select folder. So here you can see that the dataset images total found is 110. Now click on train dataset with textile images using CNN button to train CNN with above images and to calculate its prediction accuracy on test data. So here we have got CNN accuracy on textile dataset as 95% and precision recall and F-score as 100%. Now model is ready, and now click on recommend compatible items button to upload test images, and then CNN will recommend matching patterns bands. So here I am selecting this image. Now click on open button to get the recommendations test. So here is the first image, this one. You can see the user selected image, and in the next three images over here, pattern matching recommendation list for user selected shirt. Now closing these all images. You can upload with other images and test. Now click on accuracy and loss graph button to get graph. So here in this graph, x-axis represents epochs, and I took 20 epoch iterations. And here y-axis represents accuracy and loss values, and in this graph, here green line represents CNN model loss, and whereas here blue line represents accuracy. And in this graph, we can see with each increasing epochs, CNN loss is reduced and accuracy gets increased, which means generated model is accurate in prediction. So now closing this graph and coming back to the conclusion part, as technology and deep learning algorithms continue to evolve, the potential for this recommendation system to refine and optimize its performance grows exponentially. Continuous advancements will likely lead to even more accurate, diverse, and contextually aware recommendations, furthermore solidifying the system's position as a vital tool for e-commerce platforms seeking to enhance customer satisfaction and boost business outcomes. The online recommendation system using deep learning for textile products has revolutionized the way users discover, explore, and purchase items in the e-commerce landscape. This adaptability not only enhances user satisfaction but also strengthens the relationship between users and e-commerce platforms, fostering customers' loyalty and retention.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.